Hey there, I just thought I would, um, but this is my happy face, by the way. It is, serious. Um, Today when I checked my YouTube this morning, I was at 1,000 subscribers, so that is awesome. Um, I obviously I gotta thank you guys for that, being that, well, you guys are all the subscribers. I also want to thank my patrons as well. They're more of the diehard subscribers. Um, But yes, so I wanted to make just a short video, more or less just thanking everyone for the 1,000 subscribers. And I thought, well, while I'm at it, I'll just show a little bit of maybe some higher AI. Um, since I personally love AI, I love working with AI. It's one of my favorite things in the development world. And I wanted to talk briefly about the different AIs. Being a playmaker, you would think that our AI has to be FSM based, and at its core value, it does, but at the same time, it doesn't mean that's what we're limited by. So there's different types of AI out there, a few different types. Probably the most common is behavior trees. Now, the FSM AI has been around, and I think the earliest one I could find was Pac-Man, right? So I mean, Pac-Man is a finite state machine AI, and that's old as hell. FSM AI can be quite good. It is a solid AI system. I enjoy making AI through FSMs. And if you look at, I've got a little list here. You can't see it because it's hidden by my head. But such games such as PlayerUnknown Battleground, Max Payne, Grand Theft Autos, Batman Arkham City, all use FSM style AI in some way, shape, or form. Now, those are some pretty solid AI solutions, and like for games. Like if you ever play, those AIs are pretty solid. So you can make really good AI with just FSMs, right? I mean, there's several examples of good AIs. Behavior trees, newer than FSMs, since Pac-Man days, anyways, really aren't much different than the FSMs. Uh, at the core level, they're pretty much the same thing. I think they're a little more common. They are powerful. Not saying like the AI you can make with an FSM versus behavior tree, really there isn't much of a difference. The biggest difference is when it comes to scalability. The behavior tree does have the advantage. It's more modern. It can scale and create more complex AI easier than the FSM system. Not that the AI is really any better. It's just scalability. It does have the advantages. And I've got some examples of behavior trees. And some of these are phenomenal AIs. Tom Clancy's The Division, The Long Dark, are behavior trees. Spore, that's a pretty sweet game, old as hell, fun to play. Behavior tree, the Halos, Alien Isolation, probably one of the best AIs out there, is all behavior tree. Now, with that said, there, the level of complexity FSM versus behavior trees really they can both accomplish pretty much the same thing. Just behavior trees do have the advantage of the scalability is a little easier. With that said, another AI system that is beyond both of those is the utility AIs. And those are, or it's a level of a system that allows you to create. They're a lot more common in like strategy games and various things. I think you can really develop some good AI with those. Actually, I don't know if I have any really good examples. They're typically used a lot with FSMs and behavior trees, though, to control the behavior trees and the FSMs. So they're kind of a higher level that sit above them. You could also push that up another level and go to the goal-oriented action planning, such as Fear or Shadows of Mordor. It's another good one. Now, with that said, the farther up you go, the harder you push the AI in this level of complexity, the more performance costed they have. So keep that in mind. Now, like I said, now Playmaker makes, at its core, is FSM. That doesn't mean that's all there is for AI. And I wanted to show what I have here. Now, this technically isn't an AI, it's an empty game object. But this is an example structure of building a utility AI with the FSMs. So in this, I've got these three FSMs, and they really aren't doing anything. I have one just showing the stats of what would be in the AI, right? Such as, in this case, we're going to have energy. We'd have an inventory. I just kind of threw this in here that has food as a bool. We have hunger, and we have, say, money. I have the decay, which is just an FSM that's just alters these over time. Beyond that, it's not doing anything else. It's just literally getting values and subtracting them, doing a weight. Like, there's really nothing there. The doing actions is quite simple. It's this is where you would actually set your behaviors up to do actions such as walking, hunting, gathering, whatever. In this situation, because I don't actually have an AI, I just got the logic here, it really doesn't do much. All it is if we're going to eat, we're just going to say, you know what, we're going to add some value to our hunger. And we're also going to spend some money, because why not? And if we sleep, we're just going to add some energy. And if we work, we're going to gain money, and it's just on a time-based system. So they're quite small, quite simple. There's nothing much to them. Where the logic actually is based on, and I decided to layer it with game objects. For anyone's ever used it, like Game Creator, it might look similar to something like what you would see with them, maybe. I think if I was to do utility AI, like a large system, I would probably bring scriptable objects in. But this works just fine. So here I have, this is our deciding tree, and I'll open it up in here in a minute. But we have, here would be our core actions. We can eat, we can work, and we can sleep. Right? Now, with those, how do we determine which one we should be doing? So under each of those, I have other things. And these are more of the considerations to these actions. This level is given a value based on what these are doing. So for example, if I look into the hunger consideration, all it does is, okay, like in the beginning, I get the root, so if I need to use a reference to this, I can, but it just has an event called action. When it does that, it has a float value, it's called value, and it sets it to 0, and then it's going to evaluate our hunger. So from the root, it goes into our stats here, and it grabs our hunger. I take the hunger and I drop it into a sample curve, right? So if our hunger is up, up here, at 100, the value isn't very high. As the value drops, this curve comes back much higher. And that's all it does. And these aren't every frame. These are just one-time little shots. But they're all like that. They all do the same thing, right? I also have another action here for if we are currently eating, right? So based on, it's the same idea. The action, we get the value. We get what we're doing in this guy, which I'll show you that in a second, and we're just going to compare it to what were we doing previously. And if it's the same thing, I actually add a bit of value to the eat, or to the work, or to the sleep. They all three of them have this same system, and that's just due to if you start eating and the value is climbing, I want the AI to have preference to maintain that, to keep eating a bit, bring that bar up a bit before just being like, oh, I ate and my value's up a little bit, I'm just going to run away, right? So that's kind of all that is. So these just keep adding scores, right? And you can extend these as far as you can make these till the cows come home. And this could be for combat. This could be, you could have actions for do I do close range combat or long range combat? Well, what are the considerations? What is the distance to the player? Do you have a ranged weapon? Do you have visibility to the player, right? So you have all your considerations happening for what the action would be, and you make as many actions as you'd want this AI to actually perform, right? So this system, and as you can tell, I mean, I've only got 3 here with a couple considerations each. It would get on a larger scale quite cumbersome. Now with that said, I made sure to build these so that I could literally drag and drop things into here. So what happens, let's take a look at the eat in the action portion of it, not in the consideration, in the action portion, is this guy also has an event called action, and he also sets a value to 0, just the same as these guys. The difference is he has an array of his considerations, and he loops through. He tells the consideration to do its action, and then we're going to get the value that this thing has produced, and we're going to add it to this guy's total value. So he's going to loop, he's going to go through, tell this guy to do his action, take his value. He's going to tell this guy to do his action and take his value and add it. Tell this guy to do his action, take his value and add it, and then in the end he has a value. Right? And this guy can do the same thing, this guy does the same thing. Now this guy in the decision tree, he has more or less, he has a list of actions, and he's going to do more or less that same thing. He's going to loop through, tell the action, or yeah, we'll tell this action to do an action, and then he's going to get their value, and he needs to compare it to the highest value, which I'll show you that, right? So this FSM is running through all of these and just telling these to do your action, give me a value. And these guys, when they get that event, they just say, I'm going through all these guys, I'm going to tell them, do your frickin' action, give me the value. So these guys do their action, they give the value, return it to him. This guy, after when he's done his array, he gives it back to this guy. And it all happens instantly. Like, this is just an instant thing. Right? So now that we have that tree, so ultimately when this starts though, we have to know what is the highest value and what is the highest index to what we're working with, and we zero those out. Say, you know what, they're zeros. We come down, we grab one of our actions, and we're going to loop. We do a loop, we tell our action to do its action, so it does its thing, its children do its thing, we take that value. then we simply take the value and we're going to compare it to the highest value that we've had so far, which at the very start is 0, because we've just zeroed it off here. So it's going to be higher, probably. And if it's higher, then we're going to store the index that what we were just working with, so that we can remember, okay, this action is the highest and it's at this slot. Right? So we store what the value is, and we store the index. And then we're going to come back and grab the next guy, and we're going to go through the same thing. And if his value is higher, then we're going to store him. If it's not higher, we're just going to go back over here. He grabs the next guy. They do their testing, so forth. At the very end, we come over and we now look at our array, and we're just going to grab the highest one. So we're now using our index, and that guy had the highest score, so that's the one we're going to use. And I'm just going to get his name, and I'm going to compare his name to our previous action. And if it hasn't changed, then screw it, I'm not going to do anything. I'm just going to go to a next frame event and do the whole frickin' thing over again. I'm just going to keep doing that over and over and over and over and over. But if it has changed, I'm going to get the name of whatever these are, which is why they have specific names, and I'm going to send that down to our actions, and then I'm going to store that as our previous action. Right? So this is where our doing actions, we have sleep, eat, and work. And if we watch how that actually works, right, he is working, right, we can see his energy is dropping, his hunger's dropping, his money is climbing. As time goes on here, we'll soon see this work, the action we're doing as work, is going to change. He now wants to eat. So his hunger's now climbing, money's now dropping, he's now eating. We're going to hit a threshold, and he's not going to want to eat anymore here pretty quick. I also didn't cap it at 100, by the way. I should have. Now he wants to sleep. Okay, he's sleeping. I got to tweak those values a fair bit, but the idea is it is technically working. Right, so again, sleeping, it's not capped. It needs to fix that up. I have to boost the work apparently, or drop those ones, right? Because if I look at sleep, value is 0. Oh, so we have an issue. Oh, he's eating. So eating score is that. And it is a bit of a balancing game, no doubt, right? Because I mean, ultimately, I didn't put any checks to see if the money is actually like, oh, do we even have money? Because if we don't have money, then we can't, necessarily do that. But now he's working again. But he is trying to balance these three things. Like I said, now I didn't throw caps in. And if I look here, oh, we got to go into our considerations. Like our hunger, we have a value, we have our sample curve giving us a point, and like these curves I would probably need to adjust these, right, because I can move these up and down, right, to give me different effects. So all that kind of needs to be adjusted. Like is eating, I think I have it set a little high. He's currently not eating, so that's not even working right now, which is fine. He's working, so if we go into the is working, it's adding 2, and that should probably be a little less, like a 1.5 maybe. But he is going to try to balance it. Now, obviously, you have to go through and put limits and caps on it and various other little checks, I suppose. But there's a lot of tweaking. It's not like you can just throw in a bunch of random numbers and then just assume it's going to work. And that's pretty much what I did here. But the idea is that's the structure, though. We have the action we want to do and the considerations for this action, and those have scores. Now you have to kind of balance the score and what's proper. Now the other thing I don't have in here would probably be some sort of idle state that to fall back on. And well, I guess I probably need about 10 or 15 freaking different states. But ideally, that's all this system is doing. Is it's just looking at how do we keep, ourselves from energy going too low and our hunger too low, and it cares about money a little bit, but it's not a huge weight to it, right? But you can see, like, it is pushing that energy back up when it gets too low. It's pushing the hunger back up when it gets too low. So it's a matter of adjusting curves, playing up some more values, probably put in some more considerations on these things. Like I said, I just did a few just to show you the structure. So you have the main portion, the brain, controlling the actions. Each action controls the consideration. If you wanted to take that farther, these could control another layer, right? You could keep structuring it that way. But yeah, so I've only got 3, and you would, like I said, you would probably put in a pile of stuff here, right? Like if the guy had inventory, if he wanted him to go harvest a tree, well, okay, we're harvesting trees, so now you have to deal with wood. What about stone? What about the, you could have for every different resource. Okay, well, are we holding stuff? Where's the drop-offs? Is there enemies nearby? How far are the resources, right? What's the difference between, oh, well, maybe I should go work at, on a field or something, or I should go cut a tree, but the tree is like 500 meters away, the field's only like 10 meters away. So there's a lot of little things you would have to put into these thought processes, I guess you could say. All these little things that they'd have to think about. But at the end of the day, you have a system where it's like, hey, we know to go eat, or we know here, go to our bed and play the sleeping animation when we get there, and start driving this value back up for us, or go chop a tree down, right? Go to the kitchen, make something and eat it, and bring this value up. But this is, and like I said, this is where those actions would happen. He's right there. But anyways, the whole video is about 1,000 subs. That's the main portion. So, love you guys. Awesome. And it's going well, I think. I enjoy doing it. Let's keep going and just keep rocking it.